Hello students, let's discuss the concept of Newton's laws of motion, and in there we will talk about the forces. We will talk about the forces which we usually discuss in this concept of Newton's laws of motion. Now let me tell you, forces are basically they have the two effects in the form of push or the pull. If you see the word is push, it simply means if this is the point of application and you are applying the force like this, it means you are pushing that body. And if this is the body and this is the point and you are applying the force like this, then you are pulling this point. Okay, so that's the main, the concept of the force. Usually we go with the push or pull in the system. So the forces involved in this concept of laws of motion are the gravitational force. So gravitational force, very simple, okay? And another one is a tension. Another one is a tension. And then is the normal reaction. And then it's a spring force. So in today's lecture, we will discuss this all stuff in detail, okay? And it's going to be very, very simple approach too. It's very simple. Okay, now let me tell you, if you are talking about the gravitational force, if you are talking about the gravitational force, so what does it mean, dear? What does it mean? It means the very first point, very familiar point, you all are aware of that too. It's like you have placed the body over there, okay? Its mass is m, and this is your earth. And this earth is pulling this body towards its center. So this gravitational force is basically sort of mg, which you call the weight. No doubt we do have some other formula, gm1 m2 by r square, but right now we are not to talk about the massive bodies. We are to talk about very small bodies as compared to that of the earth. This is going to be the mass m. So this will be the mg. Now let me tell you, gravitational force will act on a body or a particle, will act on a body or a particle which is having the mass, If a body is not having any mass, then there will be no gravitational force. Okay. Now let me tell you one more thing. It's very simple one. Okay. Now if you say this is your box. Box is having the mass mb. mb is the mass of the box, and there you have placed another body in it whose mass is mb. Mass of the block. This is a block. This is mb. And now let me tell you, we do have some other forces in this concept too also, but I am focusing more on the gravitational force. Now what does it mean? I am focusing on it only, okay? Now let me tell you what is in there. This box is there. Box will definitely be pulled by this earth, the force mbg. And this is a block. Block is definitely pulled by the earth, which is mg. So gravitational force, one more wording is there. It's a pulling force also. Okay. It's a It's a pulling force also. Because it's not going to push anything. Like, if you have placed your body over there, and this is Earth, Earth is not going to push it, okay? Now mind it, if it's a positive mass. Now let me tell you, if you want to say, sir, is it feasible to have the gravitational force as a pushing force? I will say, okay, let it be, let's go into some hypothetical format. If you say the mass is negative, as the mass can never be negative, but ideally, hypothetically, you consider anybody is having a negative mass. No doubt that that body doesn't exist. But if that body is having the negative mass, what is in there? This Earth now will push that body away from it. You should mind it. It's very simple. But the body's mass should be negative. Only then it will be pushed up. Okay, so this is all about the gravitational force. I hope you have understood. Wherever you have placed a body, that's not the matter of concern. But if a body is having a positive mass, it is definitely going to be attracted by this. Now that's a major thing. Okay. Now let's get up to the next concept. That's the tension. That's the tension. So what do you mean by the word tension basically? Now let me tell you. Tension is what? Tension, you call it is a pulling force. Now let me brief you about that. Tension is basically a pulling force. Pulling force which comes into play, which comes into play. It's a pulling force which comes into play when the string or the thread, you say, is being stretched. It's being stretched, or you could say taut. So it's basically a pulling force. It's a very simple concept. It's a pulling force which comes into play. Now, let me give you one example. A block is placed over here, and a thread is attached to it. Let it be the two blocks are placed, and they are connected like this only. Okay, so you pull that body with a force F. Now let me give you one, let me explain you this thing, what is in there. This block will remain in there until this slackness of the string goes. So let it be when this block has moved up to there only. So now the concept has been there. These are the two blocks, A and B. It's being pulled. So now this string is there, which is taut now, which is stretched, or you could say the taut. Now, what is in there? Okay, now let me tell you. Just see. This block A, now let me give another color. This is the block A. Now, block A is pulling this thread, okay? Pulling this thread, and no doubt that is conveyed to this body B and in the form of the tension. So you could say this arrow is basically a pulling force. This is basically the pulling force. It's basically the pulling force which is acting on the body B. So in the similar way, if you talk about the B, so that's for sure, B is not going to change its inertia. So B will definitely pull this thread in this direction. B will not allow itself to move in this direction. So it will pull up this B towards itself, right? You see the arrow now. So this is there. Now you can see this black arrow I have drawn the red arrow. So what's the difference? This arrow means it is pulled by A, and this arrow means it is pulled by B. Okay, so this is there. So it comes into play when the string is being stretched, and when it's slacked, it is 0. So let's note down these concepts now. So say, if the string slacks, or you could say the breaks, then tension is 0. This is the very first point. And how about the second? If string is taut, if the string is taut, then what is going to happen? There will be tension. There will be the tension in the thread, which will always pull the point of contact to the point of contact wherever it is connected. You see there, thread is connected over here, it's pulling. Thread is connected over here, it's pulling in the backward direction. So that's the main thing, okay? So this is very simple concept of the string. Now let me tell you, we do consider the string is an ideal one. String is an ideal one. Means it's massless. It's massless and inextensible. Inextensible simply means length is constant. It's a very simple thing to say. The variation of the length with respect to time is what? 0. So this is a string. Okay. So, but what if a string is having mass? String is having mass, but inextensible. It's inextensible, but string is having the mass. So what will be there? Now let me tell you, what do I mean? This is there. So you pulled up. So what is the best part of this question? The point, wherever you mark any point, at any point, you will have the same value of the tension throughout the string if it is an ideal one. If it is an ideal string, means it is massless and inextensible, so it will have the same value throughout the string. Same value of P throughout the same string. Means if you will change the string, then that's for sure tension is going to change. But if the string remains the same, tension will be same only. But how if this part is we are talk about? It is having the mass. So let me tell you, what do we mean in there? It's like, you are pulling it. So if you mark these points, throughout, so the tension at every point will be different. It will be different. Why it is different? It's a part of discussion which we will discuss a bit later. But right now, it is of major concern. If you say the string is massless and inextensible, so wherever you mark the point, the tension will be same for an ideal string. But if the string is having the mass and is inextensible, then at every point of the string, tension will be different, though it's the same string. So this approach is very simple, very good one also. And this point is very important too, like, this one. If the string slacks or breaks, the tension becomes zero, because we'll find too many questions based on this concept, okay? No doubt it's a very simple 2-3 words sentence, but it's very important, okay? Now let me help you out with the next concept. The concept is normal reaction. The concept is the normal reaction. So what do you mean by this? Normal reaction. Normal reaction means it's a sort of contact force, the very first part. It's a sort of contact force which comes into play, only when the two bodies are in direct contact. Bodies are in the direct contact. If they are in the direct contact, then the normal reaction comes into play. And how it will act. Now let me tell you how it will act. Now let me give one example. Like this is the surface. You have placed your body over there only. So what is happening? Now, what is happening in it? Now let's check out. What's happening in there? This red portion is pushing this black portion in the downward direction, and this black portion is pushing this up in the upward direction. Is it clear? Is it clear? Now let me tell you, if I say this is body A, this is the surface. If I say what is the force on the surface due to contact, then you will say it is this force only, right? Because of red. And if I say what is the force on this block, which I have drawn like this, the red portion, then you will say it will be this force only, all right? And no doubt, this is called as the normal reaction. According to Newton's third law, they must be equal and opposite. Okay. So my question to you is, do action reaction balance each other? Do action reaction balance each other? Just need to answer that question a bit later. You need to answer, okay? Okay, now let me tell you, normal reaction is like what? It's a pushing force. Normal reaction is a pushing force and always act normal to the surface in contact. Now let me give you a few examples so that you can understand this as well. Now let me give you one example like this, a very previous example. This one. This is the body in contact. I have drawn bit like, just to understand this concept. So this is exerting force in the upward direction. This is the first example. If you talk about this is the inclined plane and you have placed a body over there only. So this is their force. Now third point is there. This is angle theta. Okay, now let me give you the third example now. What is there? Third example. You consider what you have placed a rod like this. You have placed a rod like this on there. Let it be this end is A, this end is B. A will be having a normal reaction at this direction, normal to the surface in contact. And A will be having a normal reaction in this direction, and A and then B. The surface in contact with the surface. Okay. If you say an example, this is there, this is the surface, and here what you have done, you have placed a rod like this. How the normal action like is very obvious. It's a point, and that point must be perpendicular to the surface, as if you have drawn a tangent. It's normal. Okay. This is there. One more example is there. That just note it on this example too. The point is to note for the spherical, or we would say the cylindrical bodies, normal reaction is always radial. I don't know what do you mean, because if you draw this line like this is a radial line, and if you draw a tangent to it, it will be like this only. Okay, so that's a tangent. So one of the best example is like, if like this is the cylinder, like this is the cylinder is there, and what you have done, you have placed a body like this here only, and another body here only. Okay, so what do we have in there? Check out. This surface will exert the force. This surface will exert the force. And this surface will exert the force. And all these forces, it has to pass through the origin only. Okay. Now, similarly, if you talk about this blue sphere, so blue sphere is experiencing the force there, center, and there. So these normal actions, they are definitely passing through the center only. Okay, so this is all about the normal reaction, how to show that, how do they exist, how they act. Okay, but the thing is what? It is a pushing force. Now, one more thing. When we say the body just loses its contact, when you say this word, the body just loses its contact. When body just loses its contact, what is going to happen? Yes, for sure, the normal reaction will become 0. Okay. Now, one more thing. It's very important. Right now, we have discussed 3 forces: gravitational force, we have discussed tension, we have discussed normal action, and here to discuss the spring force. Now, let me tell you, they are not the cause of one another. They are not the cause of one another. Okay. So what do I mean? Like, if you say the gravitation force is due to this force, that is not there. Okay. It's a source or the media. For gravitation to act, you should have the mass, and definitely you should have some earth or planet. If you have to talk about the tension, you must have the strength. You must have the strength. If you are having the strength, then tension will be there. Okay, I hope you got that point. Huh? Why tension comes into play? No doubt it comes into play because of stretchness of the string. Who has stretched that string is not the matter of concern. The matter of concern is only whether the stretchness in the string is there or not, whether the string is taut or not. And for the normal action, you should have the contact. If a body is not having any contact with anyone, the normal action is definitely going to be 0. Now, let me give you one example. Let me discuss all that stuff in a single question. See, this is the pulley, and you have applied the force in the upward direction. Let it be, it is a 40T, let it be 40T. And I have attached a block over here only, and this is there, and I have attached a block over here only. Okay. So you see this is there. So it's a very, very simple concept. Now, my question to you is, you have drawn all this stuff. This block is A, this block is B, and there you have drawn the pulleys, which are massless and inextensible. Okay. So the point of discussion here is what we have to discuss. What we have to discuss in this concept. Some mass MA and MB is given to you. What's mass? Okay. So the point of discussion is at what time A block and B block will be lifted off. It will be lifted off. Okay. So this is the main point of concern for you all. You need to answer this question. Let me give you examples. You may say the force is a mass of the MA is let it be, it is a 20 kg. Let it be, this is 40 kg. Something like that. Okay. So when do they lift it? So it's very simple answer. Very simple. They're very simple. Okay. As both the blocks are having the mass, so you will be definitely having the mg. And these blocks are connecting in there with the ground, so there you will be having the normal action. Okay. mb is there, mass of the block, and the normal action is going to be there. Okay. And the string is there, and you see now, it's very important. This is a string which you have attached. It's passing over this pulley and from this pulley as well. So it's a single string. You see it's a T tension is there. Okay. Tension is T there. You can see now, in this concept, I have discussed with you all that applied force was given to you. No doubt that was the applied force. But now, the three forces which we have discussed, the tension, the normal action, and the MB G, that's the mass. You need to solve this question by using the FPD. Okay, that we will discuss later. Yeah. Thank you.